Alright guys, welcome back. In this video here, we're going to look at how to convert from radical form to rational exponent form. So the definition is if you have a to the power 1 over n is equivalent to n root of that number a, or the general form will be, if you have the power where you have m on the numerator and then n on the denominator. This translates to the n root of that number, a raised to the n powers, right? So sometimes radical expression is easier to simplify in this form or this form or vice versa. It depends which form we prefer working with. So let's look at example 1. We just want to write the following radical expressions and simplify it if possible. So let's look at 25 to the power 1/2. So it's hard to imagine what this looks like because if we define exponent as, let's say we look at 3 to the second power, and that means we take the base times itself, and that gives us 9. It's hard to imagine or kind of wrap around what does it mean to have 1/2 powers. But if we use the radical form, this becomes the square root of 25. So 25 is 1/2 power. It just means you just square root the number 25, right? So in this case, it's going to be 5. All right, so over here, again, it's hard to imagine or kind of like physically just kind of try and grasp the understanding of what does it mean to -8 raised to the 1/3 power in terms of the definition of exponent, right? So instead of going that route, we're looking at radical form. We can say this is the same thing as third root of -8 to the first power is the same thing. So in this case, it's going to be -1. So this is to the first power. It won't change the answer there. Here, what we can do here is we can change this to the square root because 1/2 is square root, and 36x to the 16, right? And then what we can do here to simplify is we can say, okay, what number square to give us this here? What number square give us that? So let's see. I know that 6 square will give us that, and then x to the 8 square also give us that, because this right here time itself will give us 36x to the 16th power. All right. Okay, so let's look at some more radical exponent, radical form to rational exponent form. I think in this one we just want to rewrite from radical to rational exponent. So let's look at this one. This can turn into 9z to the 1/3 power because this is to the first power and then the index is 3. Here we can say x to the third y over 4 all raised to the 1/7, right? And here we can say 5x. Right, this is to the first power, and this is squared, so that's 1/2, right? Okay. Let's see. I think I've already done this one here. That was just the n root of a to the n, right? Let's look at some more examples. 125 to the 2/3 powers. If we translate this to rational exponent form, we can have third root of 125 squared. Okay. So, we can square 125 and take the cube root of that. So it's instead of doing that, because it's taking a while to figure out what is the third root of 125 squared, and that's going to be really huge. Instead of doing that, we can actually rewrite this as cube root of 125 first, and then bring the powers outside. So we're allowed to do that, because if you look at this here, it's the same thing as 125, 1/3 times 2. So that's where we got the cube root of 125 first and the 2 outside. We do know what the cube root of 125 is. That's 5, and then the square comes down, so the answer is 25. If there's a negative in front of the number like this here, we want to keep that outside when we convert to radical form. So it's going to be negative square root 36 to the third powers. Okay. All right. So instead of taking the square root of 36 to the third power, I don't know what that is, 36 to the third power, that's 36 to the third, that's like 46656, and how the hell are we going to figure out what the square root of that is? So it's hard to do that. So instead, okay, we can do this. We can say square root of 36 first, and then raise that to the third power afterwards. So negative, so this is 6 to the third, so that is, I think it's 218, so negative 216. Negative exponent, if you recall, negative exponent, it just means the reciprocal, it's just 1 over a to the n power n, right? Or if it's in the denominator, we bring that to the numerator, so that's just m of n there, right? Okay, that's some more example of simplifying negative exponent with radical form. I'm just going to do one of these here. We're going to go ahead and bring this up to the top. So that becomes 2/3. Change that to radical form. Cube root 64 squared. Let's do the cube root first because it's easier. So that's 4 squared, which is 16, right? Exponent form with fraction exponent, okay? We can say this is same thing as 16 2/3 plus 5 6 because using exponent form, exponent rule, sorry. 16, and that becomes 2 2 4 4 plus 5 over 6. So that's 16 9 6. And then that becomes 16 3 half. And that becomes square root of 16 to the third. So that becomes 4 to the third, which is 64. Okay. And you can do the same thing here as well, but you want to subtract those. Or you can bring this up to the numerator. Either way is fine. I'll let you guys finish that one. There's some more example over here as well. I do want to get to example like this here. Let's see, something like this. Okay. This one said use rational exponents to simplify the radical. Yeah, I guess we can do this here. So notice that you know there, if we change this to rational exponent, this becomes 27a squared b squared to the 1/3 power. And we can distribute the 1/3 to each of these terms here. And that becomes 27 to 1/3, a to the 2/3, b to the 2/3. 27 1/3 is just cube root of 27, so that becomes 3, a to the 2/3, b to the 2/3. So you can write like that if you want to. I think I'm gonna let you guys work on this more and then come back with questions.